Welcome to my presentation. This presentation is part of the playlist Integral of Logarithmic Functions. In this presentation, we're going to solve example problems related to logarithmic functions. So let's look at some example problems. We want to evaluate a function integral 1 plus e to the power of minus x divided by 1 plus x e to the power of minus x dx as shown here. So before we solve this example problem, we want to simplify the example problem as shown here. So we're going to take the numerator part, we're going to take the denominator part and then rewrite it as shown here. We can write it as 1 plus 1 over e to the power of x, that's the numerator part, divided by 1 plus x over e to the power of x, that's the denominator part. Okay, so we're going to take the common denominator for the numerator part, common denominator for the denominator part. So the common denominator for the numerator part is e to the power of x, and then the numerator for that is going to be equal to e to the power of x plus 1, the whole thing divided by the common denominator for the denominator part is e to the power of x, and then the numerator part is going to be e to the power of x plus x, like that. So when we simplify that, the e to the power of x and e to the power of x cancels out, leaving us with e to the power of x plus 1 divided by e to the power of x plus x. Okay, now we are ready to solve this given example problem. So we can rewrite this given problem as equal to e to the power of x plus 1 divided by e to the power of x plus x dx. Now, we're going to substitute u as equal to e to the power of x plus x. That is what is in the denominator. So since u is a function of x, we're going to differentiate u with respect to x. Du by dx is going to be equal to e to the power of x plus 1. So d by dx of e to the power of x is e to the power of x. D by dx of x is 1. Okay, so therefore, now I can rewrite this as du is equal to e to the power of x plus 1, the whole thing, times, or that's in the parentheses, times dx, like that. If I want to express it in terms of dx, I can write dx on the side. Dx is equal to 1 over e to the power of x plus 1 times du. Okay, now we're going to substitute u as equal to e to the power of x plus x, and dx is equal to 1 over e to the power of x plus 1 du into the given example problem, and then use the rules of integration and then solve it. So our example problem is e to the power of x plus 1 divided by e to the power of x plus x dx, right? So we can write this as e to the power of x plus 1, which is the numerator part, and the denominator part e to the power of x plus x, we said let that be equal to u, and therefore we replace that by u, and wherever we see dx, we're going to write it as 1 over e to the power of x plus 1 du. So as we can see here now, that we have e to the power of x plus 1 in the numerator, e to the power of x plus 1 in the denominator. So those terms cancel out. And when we simplify it, it simplifies to integral 1 over u du. So we know that integral 1 over u du translates to ln of u, like that, plus c, where c is a constant of integration. We need to express our solution in terms of x and not in terms of u. So therefore, wherever we see u, we go to replace it by e to the power of x plus x. So therefore, we can write this as ln of e to the power of x plus c, where c is a constant of integration. This is the way we're going to solve example problems related to logarithmic functions. Let's look at another example. Let's say we want to evaluate the integral of 1 over square root of x plus 1 dx. Okay, we're going to use the logarithmic rule to solve this example problem. So we're going to let u be equal to x plus 1. That is what is in the denominator without the radical term. So since u is a function of x, we're going to differentiate this function with respect to x. Du by dx is equal to 1. not e to the power of x. This should be equal to 1. Okay, so just ignore that. So therefore we can write this as du as equal to 1 dx. So, or we can write dx is equal to 1 du, right? Now we can substitute u as equal to x plus 1 and then dx as equal to 1 du. We're going to substitute these into our given example problem, use the rules of integration, and then solve it. So therefore, our given example problem is integral 1 over square root of x plus 1 dx. So wherever we see x plus 1, we're going to replace it by u. And since that is under the radical term, we're going to put a radical term over u as shown here. So integral 1 over square root of u du. So 1 over square root of u du is going to be equal to ln of square root of u as shown here, right? We know that integral 1 over u du is equal to ln of u. Since we have square root of u, it is going to be ln of square root of u plus c, where c is a constant of integration. As we mentioned, we want to be able to express our solution in terms of x and not in terms of u. So therefore, wherever we see u, we're going to replace it by x plus 1. And therefore, we're going to rewrite this as ln of square root of x plus 1 plus c, where c is a constant of integration. So this is the way we want to solve example problems related to logarithmic functions. In my next video presentation, we will be solving more example problems related to logarithmic functions.